Ever drop your keys? Or
Yeah.
just, stand there, not floating away. It seems obvious, but it's all down to this invisible force we rarely think about. Today, we're doing a deep dive into gravity and gravitation. We're looking at a foundational science overview. Okay, let's unpack this. See what the core ideas really are.
Yeah, and what's fascinating here is this isn't just about why things fall down. It connects, well, everything from you sitting there to planets orbiting stars. It's truly cosmic glue.
Okay, so starting simple. The source defines gravity basically as a natural pulling force. Always a pull, never a push, and it acts between any two things that have mass. So it's not just Earth pulling an apple, it's everything pulling everything else.
Exactly. Every single object pulls on every other object. It's universal. The Earth pulls the moon, sure, but the Earth also pulls you, keeping you grounded. And technically, you're pulling back on the Earth, too, just obviously with a much smaller effect.
Ha, right. My personal gravity isn't shifting continents anytime soon. Okay, so that's the what. Now, the how. That brings us to Sir Isaac Newton, doesn't it? His law of universal gravitation. He kind of figured out the rules.
He really did. Two main things to grasp from his law. First, the force is directly proportional to the masses. So basically, more mass means more gravitational pull. Simple enough.
Bigger things pull harder. Got it.
But the second part is maybe less intuitive. The force is inversely proportional to the square of the distance between them. That square is important, double the distance. The force isn't half, it's only a quarter of what it was.
Whoa, okay, so it weakens really, really quickly as things get further apart.
Very quickly. And Newton tied it all together with g, the universal gravitational constant. This is an incredibly tiny number, about 6.674 times 10 to the minus 11th. The units are Newton meters squared per kilogram squared, but the point is, it's small.
And here's where it gets really interesting and kind of counterintuitive, right? The source gives this example. Two 1 kilogram masses, like bags of sugar, sitting a meter apart. The gravitational force between them is that tiny number, 6.674 times 10 to the minus 11th newtons, which is practically nothing.
Absolutely minuscule. Like the weight of a bacterium, as you said earlier, it's mind-bogglingly weak on human scales. That's why you don't feel pulled toward your coffee cup, even though technically you are. Earth's pull just dominates completely.
Okay, so that's the universal force. But what about the everyday effect? Things falling. That's where G comes in, right? Acceleration due to gravity.
Exactly. On Earth, gravity makes falling objects speed up, accelerate. And that acceleration, g, averages about 9.8 meters per second, or meters per second square. So each second something falls, it picks up another 9.8 meters of speed,
Yeah.
roughly.
And if something is falling only because of gravity, with nothing else interfering, that's free fall. Now this raises an important question, one that still trips people up. What falls faster, a heavy thing or a light thing, like that classic feather and bowling ball example?
Oh, yes. Our intuition, shaped by air resistance, tells us the heavy thing falls faster. But the science, and our source confirms this, says something amazing. In a vacuum no air, they fall at the same rate. Mass doesn't matter for the acceleration rate in free fall. A feather and a bowling ball. Plop. Same time.
It's wild. You really need to see it, like those videos from the moon, to kind of believe it. Okay, so gravity makes things fall. But it does way more than that, right? If we connect this to the bigger picture, it's fundamental.
Oh, absolutely fundamental. Think about the solar system. Gravity keeps planets, including us, locked in orbit around the sun. Without it, we'd just fly off into space.
Yeah, that would be bad.
Definitely. And it causes ocean tides, too. That's mostly the moon's gravity pulling on Earth's water.
Wow.
Plus, and this is crucial for life, gravity holds our atmosphere onto the planet, keeps our air from just drifting away.
Wow. Okay, so it's not just falling apples, it's orbits, tides, even the air we breathe.
Yeah.
So wrapping this up, the key takeaway. Gravity is, well, it's this universal pull. It affects everything with mass, shaping things from tiny interactions right up to the whole cosmos. It's inescapable.
It really is. It structures the universe as we know it.
So what does this all mean for you? Maybe just take a second next time you, I don't know, drop something or just feel your feet on the ground. Ponder what it would be like without this constant invisible force governing absolutely everything. How different would reality be? It's pretty fundamental stuff.